Okay, welcome to Applied Mathematics 1, Lesson 7. Derivatives of trigonometric functions. So have you discovered about the derivatives of trigonometric functions with same as the sine and cosine functions? Let me tell you how to calculate by using the derivative. For example, f of x is sine x. Let's derivate it. F derivative at x must be cos x. And the f of x must be cos x. Its derivative, it will become minus sine x. And the f of x tan x must be f derivative at x must be sec x square x. And the second, derivatives of sum and difference of two functions. If f and g are differentiable at x naught, then f plus g and f minus g are also differentiable at x naught. And their derivatives are given as follows. F plus g derivative at x, which is equals to f derivative at x plus g of g derivative at x. Then f minus g derivative at x must be f derivative at x minus g derivative at x. Here is the example. On the practical examples on derivative of the sum or difference of two functions. For example, 2x to the power 4 minus 5x squared plus 7x minus 11. On the second example, 4x cubed plus 5x squared minus 11x plus 12. What shall we do first? 2x to the power of 4 minus 5x squared. Let's divide by that. Let's make division by the terms. 2x to the power of 4 minus 5x squared derivative prime. So let's derivate it here. So it must be 8. We have derived by nx the power of n minus 1. 8x the whole 8x cube minus 5x squared 10. 10x must be. Then on the second derivation, 7x minus 11 prime. 7 it must be 7 x the power of 1 minus 1 0. X the power of 0 must be 1. 7 times 1 must be put here 7. So it must be the correct 8x cubed minus 10x plus 7. But 11 it's constant, it will become 0. Second example, 4x cubed plus 5x squared minus 11x plus 12. Here 12x squared plus 10x minus 11 plus 0. So the derivative must be 12x squared plus 10x minus 11. So we can identify it like this. And the derivatives of product and quotient of two functions. If f and g are differentiable functions at x naught, then the product fg is differentiable at x naught and its derivative is given as follows. While f and g are differentiable functions and g of x is different from 0, then f divided by g is differentiable for all x at which f and g are differentiable as follows. Fg derivative at x naught. F derivative at x naught times g derivative g x naught plus f of x naught times g derivative at x naught. Then, and the division f over g derivative at x naught must be f derivative at x naught times g times x g of x naught minus f of x naught times g derivative at x naught over g of x naught square. On the practical examples, then number 1, f of x equals to x plus 5 times x squared plus 1. Then let's derivate it by using fg derivative at x. F derivative at x naught times g of x naught plus g of derivative at x naught times f of x naught. So x plus 5 prime times x squared plus 1 plus x squared plus 1 prime times x plus 5. If we derivate x plus 5 prime must be 1 and x squared plus 1 plus if the x squared plus 1 prime must be 2x times here x plus 5. Then x squared plus 1 plus 2x squared plus 10x. Then x squared plus 2x squared plus 10x plus 1. There is a collect like terms. Collect like terms, add 3x squared plus 10x plus 1. Here, on the second example, f of x must be 4x squared minus 5x plus 7 over x squared minus 3x plus 1. Here, we can determine by using the quotient rules, such like f derivative at x times g of x minus g derivative at x times f of x over g of x squared. So let's say here, for x squared minus 5x plus 7 prime times x squared minus 3x plus 1 minus x squared minus 3x plus 1 prime times 4x squared minus 5x plus 7 over x squared minus 3x plus 1 square. Then let's derivate it. For x squared minus 5x plus 7 prime, 8x minus 5 times x squared minus 3x plus 1 minus 2x minus 3 times 4x squared minus 5x plus 7 over x squared minus 3x plus 1 square, which is equal to minus 7x squared minus 6x plus 16 over x squared minus 3x plus 1 square. So this is all about applied mathematics. So thanks for listening.